This problem is asking you to determine the volume of carbon dioxide that is formed at STP when 31.2 grams of pentane is burned. But this would usually this top part would be all that's given. And students often freak out when they see this because it looks like way too little information to do anything. You don't even see an equation. But the steps to getting this correct are recognizing that pentane is a fuel and it's being burned. The real word here is what is burned. Burning indicates a combustion reaction. And combustion reactions are standard in many ways, and the only thing that will really change in a combustion reaction of a hydrocarbon or a carbohydrate is what is actually burning. So I'm going to write down what is staying the same. The standard parts of every combustion reaction would be oxygen in the form of a gas will combine with something that is burning to produce. And when we're talking about something that's burning, we're going to assume that it's going to be a carbon-based compound, such as a carbohydrate, a hydrocarbon, or an alcohol. Those are the only ones we'll deal with as far as types of combustion. A carbon-based compound, which this is, because it starts with a carbon, burns in the presence of oxygen gas to produce carbon dioxide gas and water vapor gas. Now we can fill in what was burning, and we know that C5H12, which is a fuel called pentane, it's similar to propane, butane, octane, hexane. They're alkanes, they're hydrocarbons, and that 5 should be a 2. And these are burning. So it's a combustion reaction. Once you recognize as combustion reaction, all of these things here, these are standard. Now you've got to balance it. So I'm going to move this so that we have some room. So I'm going to move this apart. Let me cut it, move it over. Alright, so with this equation, now we have to balance it. According to the Cho rule for balancing most combustion reactions, you look at carbon first. So the Cho rule says carbon balanced first, and then hydrogen, and then oxygen. So to balance the carbon, I have to put a 5 in front of the carbon dioxide because that is the only place where carbon will end up. Assuming that 31.2 grams of pentane completely burns with excess oxygen. Carbon is balanced, so now I want to look at hydrogen. I have 12 hydrogens on the left and 2 on the right. In order for me to factor up a 2 for the hydrogen up to a 12, I need to put a big 6 out in front. My hydrogens and my carbons are balanced, so the next step is oxygen. So this is where I look at the left, I look at the right, and I count out the total number of oxygens. So the 5 times that 2 gives me 10 oxygens here. I'm going to put 10 oxy. And then this 6 times that 1 gives me 6 oxygens. That's a total of 16 oxygens on the right, which means I have to get 16 oxygens on the left from 2. Remember, you don't add, you're multiplying. So if each of these is an oxygen, so this is oxygen, I'm going to need, in order to get 16, I'm going to need 8 of these. So I'm going to put a big 8 there. And now our equation is balanced. And that is the very first step. The first step was to first figure out the complete equation and then balance it. The only thing that will change in combustion reactions for this class would be what is actually burning, and the rest will be standard if it's a carbon-based compound and it burns completely. The next step is, scrolling down to the next page, it says, now we actually have to do the stoichiometry. Determine the volume of carbon dioxide that is formed at STP when 31.2 grams of pentane is burned completely. We've already done this step. We've already figured out the complete balanced equation, so that reaction itself. Now we have to actually do the stoichiometry. And this is easier to do, of course, with the equation. Otherwise, there's no chance of you getting the correct answer without having an equation in front of you to work with. So we start with what we know, and what we know is we have 31.2 grams of pentane. And our target, what we're going toward, is volume of carbon dioxide. So 31.2 grams of C5H12 over 1. We need to get rid of mass, and to go from mass of a compound to moles of a compound, you use the molar mass. 1 mole of pentane has a mass of 72.15 grams, which you would get from the periodic table. Adding up the 5 carbons plus the 12 hydrogens will give you 72.15 grams for 1 mole of this compound. So now we have moles of pentane. We just got rid of grams by using the molar mass, dividing by the molar mass. We're going to go from moles of pentane, which would be C5H12. We want to find out how much carbon dioxide is formed, so we're going to go from moles of pentane to moles of carbon dioxide. And according to the balanced equation, so the big numbers in front, there's a 1, an invisible 1 in front of pentane, an 8 in front of oxygen, a 5 in front of carbon dioxide, and a 6 in front of water. For this problem, we don't care about how much oxygen is needed. We don't care about how much H2O is formed. We want to find out the volume of CO2 that is formed, so we've got to use that 5 for the molar ratio between the carbon dioxide and the pentane. Let's check to see if something is canceled out. Our moles of pentane are gone, and we have moles of carbon dioxide. The next step is how do we go from moles to volume, which is our final destination. We're going to go from moles of carbon dioxide to liters of carbon dioxide. And that relationship, of course, is 22.4 liters per 1 mole of carbon dioxide, or any gas at STP. So moles of carbon dioxide are gone. We have liters of carbon dioxide as our final upper right unit. And the math will give us, with sig figs, 48.4 liters of carbon dioxide will be formed when you burn 31.2 grams of pentane at STP. If this were happening in the open air, of course, oxygen will not run out. What will run out first is what you're actually burning. Air all around the world, of course, is filled with tons of oxygen. So you're going to run out of what you're burning before you run out of oxygen, which means oxygen is usually going to be excess anyways. But you read the equation, you read the problem for what it says, and then you solve it accordingly. And this would be our answer for the volume of carbon dioxide formed from a limited amount of something that is burning.